Okay, I'm sorry about the second part. I mean, the video went too long. Anyways, let's solve it. So this will be half minus 2 cosine 2a as it is. Now the next step is we want to distribute this into both of these. So what do you get? So we get 2 sine square. Wait a minute. Two sine square b cosine 2a. Okay, it's cosine. 2 cosine 2a plus 2 sine square b. This is what we get. Plus 2 cosine 2a plus 2 sine square b cosine 2a plus 2 sine square b. Is that, do you understand? Is that clear? Did you understand that? Now, let's move on. Let's move on to the next step. So what should we do next? Minus 2 cosine 2a is there, 2 sine square b is there. Okay, but we don't want 2 sine square b because with cosine 2a we have cosine square b. So we want cosine square b. Okay, so let's multiply the whole thing by half. Then we get minus 2. That 2 disappears. Cosine 2a. Okay, then plus sine. Okay, we want to change sine square b into 1 minus cosine square b, and then times cosine 2a. Then again the 2 disappears, and it will be, I want to change sine square b into 1 minus cosine square b again. Why do I want to do that? Because as you can see, okay, we do have sine square b there. Okay, so we better keep sine square b. We better keep sine square b. Does that make sense? 2 sine square b should be there. Why did you keep 2 sine square b? Because we do see that we have sine square b there. Now, do we have anything left? No. Here is the eraser. Okay, let's move on. So which step did you do? Oh, we did this. So what do you get? Next is minus cosine 2a, then plus, let's distribute cosine 2a into this. We got cosine 2a minus cosine square b cosine 2a plus 2 sine square b. Okay, do you think there should be 2 there? I don't think so, because I think when you multiply it through by half, the 2 should have been disappeared. I magically wrote 2. So yeah, minus cosine 2a, this disappears. We can have sine square b there, sine square b minus cosine square b cosine 2a. This is the thing that we wanted to prove. You can match it there. Sine square b minus cosine square b cosine 2a. So we have our end goal proven. Okay? Proved. Wait a minute. But I want to give you a device to solve this problem. When I replaced cosine 2a there with this formula, 1 minus 2 sine squared a, I think it would be better to replace it with this cosine squared a minus sine squared a. Why I think it's better to replace with this? Because we have both cosine and sine, and whichever is the need, we're going to disappear that. Does that make sense? We're going to vanish that according to the need. But here we have to retransfer into cosine if we need cosine, and retransfer this into sine. I mean, we have to keep it if you want them in the form of sine. That's why I guess I use this formula, but it will be better to use this. Okay? This is the advice that I wanted to give at the end. Okay, after doing this. problem. Anyway, this is the solution to the problem. This is how we prove it. A little tricky to prove it. Okay, this was a little tricky to prove and know the steps. But before leaving, I want to summarize what I've done here, what I did to prove it. So the first thing was change sine square and cosine square A into 2A, because we have 2A there. 2A. So how do you change into 2A? Have somehow 2 written in front of this. We're not going to do it magically. We're going to multiply it by half and then going to do and multiply it by 2. So there is no effect. Okay? And then it becomes 2. It'll become 2 sine square b, and we can replace 2 sine square b with this formula. According to this formula, it becomes in the form of 2a. This also becomes in the form of 2a. And then the next step is write cosine 2b in terms of b's, only there, and then solve it. Solve the stests, and you'll get what you wanted to prove.